Hey guys, my name is Arash. In this video, I'm going to show you how to solve the lesson 1 of Codility. Codility apparently is a platform which helps recruiters evaluate basically their candidates, and basically once you apply to a job, the recruiter, if they found your resume interesting, they will send you a link, and that link bring you to Codility, and you will have to do a test, and basically if you pass it, you go to the next rounds of interview. And how I came across this was that I applied to a junior position at American Express, and they sent me a link, and to be able to prepare for that, I thought it's a good idea to start solving the lessons on Codility. So that's what I'm going to share with you. The first lesson is binary gap, and I've already solved this one, and I'll show you. Like I got 100% and it took me 22 minutes. And here's the task description. This is the task description. Feel free to pause the video here, go ahead and read it and try to solve it, and then come back and see my solution in JavaScript. Okay, I guess you've done that already, and let's go ahead and see how to deal with it. So what does it ask us to do? A binary gap within a positive integer n is any maximal sequence of consecutive zeros that is surrounded by ones at both ends in the binary representation of n. Alright, so what we're gonna need to do is to get this n and change it to binary format and see what is the maximal binary gap length in this binary format of n. Here is saying that write a function solution n that given a positive integer n returns the length of its longest binary gap. The function should return 0 if n doesn't contain a binary gap. Okay, so first of all, let's figure out how we can translate a base 10 integer to binary. So I open a notepad, and I'll show you here how we can deal with it. So for example, let's say we're going to deal with 16. We want to, for example, change 16, which is base 10, to binary format. And to be able to do that, we're gonna need to divide by 2. Okay, I put 2 over there, so we know that we're gonna need to do that. And yep, this looks good. Okay, 16 divided by 2 is 8, and let me put some gap here so we don't get confused. 16 divided by 2 is 8, and the remainder is 0. So I put 0 here, and I put 8 here. So again, we do the same thing. 8 divided by 2 is 4, the remainder is 0, and the value, the result is 4. And 4 divided by 2, the remainder is 0, the result is 2. 2 divided by 2, the remainder is 0, the result is 1. 1 divided by 2, the remainder is 1, and the result is 0. Okay, that's how we're going to deal with it. Like, we see the whole number as a result, and what is the remainder. That whole number needs to reach out to the value that we are dividing. I think it's quite straightforward. If it's confusing, comment down below and tell me to dive deeper in showing you how to change to binary. But I think it's pretty straightforward. So once we have all these remainders, once we got to 0, we won't continue dividing anymore because it doesn't make sense. It's always 0. And once we have all these values, all these remainders, we go ahead and write them from bottom to top. So it will be 1, 0, 0, 0, 0. This is the binary representation of 16. And you can test it quickly. We have 0, 1, 2, 3, 4. So 2 to the power of 4 plus, oh wait, to the power of 4 plus, I'm sorry. Yes, we have 1 times to the power of 4 and 0 times 2 to the power of 3 plus 0 times 2 to the power of 2, and the same for the rest, 0 times 2 to the power of 1 and 0 times 2 to the power of 0, right? So all these other terms will end up being 0, and this will be 1 times to the power of 2 to the power of 4, which will be 2 times 2, 4 times 2, 8 times 2, 16. So that's correct. That was an accurate translation to binary. Okay, so we're gonna need to implement this logic in our code. Let's go ahead and see how we can do that. In my solution, I said that before. I've written the solution in JavaScript, so it's pretty straightforward, and I'm going to explain to you. I think you will get the idea, and if you want to implement it in different languages, then you can. So here's our function, and our solution is this long, so it's not that complicated. And what I do is that first I declare and instantiate some variables which are going to help me throughout the solving of this problem. The first one is I've called it found1. Is Boolean variable, and I initialize it with false. And what it does is that it checks, because we're going to create this binary number from least significant to the most significant. As you saw, we first created this one, then this one, then this one, and once you bring it here from left to right, you see that we're getting the result from least significant towards the most significant, which is 1. And we're going to go through this in the code as well in the same order. And this variable found1 is going to check if we find any 1 here or not. So for example, if I start counting all these zeros, and at the end I return 4, for example, I say, okay, I found a binary gap of length 4. Well, it's not correct, because there is no 1 here to hold all these zeros. We have a 1 here, but we don't have any 1 here. So we're gonna need to make sure that we find a 1 here or not. And we know that always we're going to have 1 at the end, because it doesn't make sense to put 0 at the end. It doesn't count anything, right? So we know that we have at least 1 at the end, and we're gonna check if we have 1 this side or not. Or for example, there can be a situation that it would be 1 0 0 0, for example 1 okay, let's say 3 0 here, and 1 2 3 4 zeros here. And here, for example, if we count all these all these zeros, the number is 4, and here the length is 3, but we're gonna need to return 3, because this is the gap and this is not the gap, right? So we're gonna need to check to see if there is an initial 1 or not. Okay, enough talking, let's go and see what's up. So this found one is checking if we find a 1 like in the beginning or not. Then we go ahead and we have div result. This is div res, which stands for division result. This is basically this. Initially it's equals to n, which here was 16. Then it is the result of dividing itself by 2, and each time we divide it by 2, and we get the floor. So for example, if here it was 15 instead of 16, we would divide 15 by 2, and the result would be what's that? 7.5, right? Yeah. The result would be 7.5, but we don't deal with 0.5. We don't deal with decimal. We get the floor. So we would say it's 7, and so we would say 15. We would say 15 divided by 2 is 7, and the remainder is 1, because 7 times 2 is equal to 14, plus 1 is equal to 15. Okay. I guess that's kind of clear. I hope so, at least. So that's about this one. And max gap. This is basically what we're going to return at the end. And zero count. It stands for zero counter. It counts the zeros as we're going through, and sometimes we reset it to 0. So I will tell you when we will do that. Okay, that's all for declaration of these variables. Let's go ahead and enter to our actual logic. Here is a while loop. We say while division result is not equal to 0, do this loop, right? We go through this loop until the division result will be equal to 0. So why do I do that? Let's go back here to our example. Here is our initial value of division result, and which is the actual n, and it goes down and down, and eventually it gets to 0. It doesn't matter what number we start with, eventually it gets to 0. So once it gets to 0, we don't want to divide anymore, so we stop there. And that's our stop condition. Then we enter the loop, and here we have an if statement and also an else if statement. Let's see what we're doing here. We check if division result is odd. So here we say if if div res mod 2 is true, basically if it returns 1, it means that it's odd, right? If the return value of mod operation is 1, then this if statement then it will be evaluated to true, and this block of code will be executed. If from the other hand, if it's 0, so it can be either 0 or 1, like a number mod 2 can be either 0 or 1, right? And if it is 0, then we go ahead and check this condition. But let's go through this one. Let's imagine that it's odd. and we say, okay, if it's odd, then we know that we found 1. So we say found 1 is equal to true. Why do we know that? Let me go through the example again. Here, once let me see. Okay, here we're checking the remainders, right? These are the remainders. These remainders are 0, 0, 0, 0. This remainder is 1. And once we found a remainder of 1, here we put a 1, right? Once we find a remainder of 0, we put 0. So that's what we're doing. So actually, once we if we, for example, are starting, let's go ahead and try another example. Let's go ahead with 15, and we say 15 divided by 2 is the floor is 7, and the remainder is 1. So we do this, and then we say 7 divided by 2. The result is 3, and the remainder is 1. So 2 times 3 is 6, plus 1 7. Okay, and we do the same thing here. Divided by 2 1, remainder is 1. Sorry, 1. So 2 times 1 is 2, plus 1 is 3. And here 1 divided by 2 0, the remainder is 1. So here actually the binary representation is 1 1 1 1. 4 ones. So imagine we got 15 here as our initial value, and we entered it, and we see that, okay, 15 mod 2 is what? Is 1. So we say we found a 1. So we say, okay, this is true. Which one did we find? We found this one, which maps to this one. Remember, we're writing from bottom to top. So the remainder that we found at the end is the digit that we write on the left side. And it was the same here as well. Okay, so we say we found the 1. So if we find zeros now, we can start counting them. But if we didn't find this 1, for example, in this 16 example, there is no 1 here, right? There is no 1. So we're not going to count this. It's pointless. Okay. So if we found 1, we set this to true, and we restart the 0 counter. So we say 0 count is equal to 0. Now in the beginning, we haven't started the 0 counter, because we were waiting for finding a 1, then we started 0 counter. So this was 0 already, and we set it to 0 again, so no big deal. Okay, now let's say that we found a 1, we're going to the next digit, and we say else if. So we got to the next digit. The next digit, let's say, is not 1. So it's 0. The remainder of, by the way, this div result at the end, I will change it, right? I would say that divres is equal to math.floor, divres divided by 2. Exactly what we're doing here, right? Divres is 16, 8, 4, 2. So math floor, why? Because, for example, 16 divided by 2 is 8, floor of 8 is 8. But 15 divided by 2 is 7.5, floor of 7.5 is 7. So that's why we're doing math.floor. So right now, imagine that we're on the second iteration, and it's not 1 anymore. This is not 0, 1, 0, right? We found the 1, we found 1 to true, now it's 0. Now we go ahead and say, okay, else if found 1. So in the else statement, we check if we already have found a 1 or not. Since we have found the 1 in the first iteration, we enter this block of code, right? So pay attention here. In the second iteration, the div result mod2 is not equal to 1. That's why this block of code didn't execute. We got here. So we know, by getting here, we already know that this is a 0 that we're dealing with. So we check if there was a 1 beforehand or not. If there wasn't, if there was all zeros beforehand, then we're not gonna count this 0. So we skip over it. We skip it and we divide the div result with 2 again and go through it. And until we find a 1, then we set this value to true and we count the zeros. I hope I'm not over explaining, but I just want it to be clear. So we got here and let's say we had a 1, now we have a 0. So we've set this found 1 to true, so we enter this block of code. Now we say, because we have a 0 and we had a 1 already, we start counting, we increment 0 counter, right? 0 counter, 0 count plus plus. And then we say if 0 count is more than max gap, so we're looking forward to return max gap, right? The maximum length of the binary gap in this binary representation of n. So we initialized max gap to 0. Now we now we found 1 0, which has a 1 like on the right side. So 0 count is now 1. And it says, is 0 count more than max gap? Yes, 1 is more than 0. So max gap is equal to 0 count. Now max gap is equal to 1. And we go ahead and divide this div result, and we go ahead, and if we have another 0 here, then again 0 counter will be incremented, and then again max gap needs to be updated because not 2 is more than 1 until we get to a 1. So for example, let's say we found 2 zeros, right? We found 2 zeros and now max gap is 2, and we got to another 1. So it was 1 0 0 1. Now this time we are here again. And as we said, here we found a 1, so we enter to this block again, and found 1 was true already because we had we set it here. So this is basically for the initial one, and we found 1, so no worries with that. We again set it to true; it doesn't change anything. But what is important here is that we restart the 0 counter. Right? We restart the 0 counter. So now we have 1 0 0 1, and we know that the max gap is equal to 2. 0 counter counted this 2, and now if there are zeros again, we count them from 0 again. Why? Because our 0 counter now is equal to 0, so it's ready to count the following zeros, if any. And if there is no zeros, then like we go ahead, or if there is no gap of length more than our max gap, then we already have our max gap length, and at the end we're going to return it anyways. So anyways, we go through all the digits, and at the end this max gap is the result that we want. So that's it for this, and you can see that all the test results are passed here. And yeah, that's it for this video. I hope you enjoyed it. If you have a better solution, go ahead and comment it down below. I'm really looking forward to see your solutions and see if someone can come up with a better solution. But I think it's a good enough solution, and honestly, I kind of like it. So if you have any idea, if you want to see, I don't know, me creating in detail video about changing the integers to binary, also comment it down below. And just if you like the video, please hit the like button and subscribe to my channel and hit the bell notification so you will be updated once I post new videos. And that's it. Next time I will see you with the next video from this Codility lessons. Peace.